This is the Gravity Engine tutorial on binary objects. And here we are starting with a empty scene that I've added a few little utility functions to. First of all, I have created an object that has a gravity engine on it. I have grabbed from the Gravity Engine prefabs directory the mission camera, which allows me to just zoom with the mouse wheel and rotate around. And I've also added an object called time zoom where I've attached the time zoom script. And this just allows me to speed up gravity engine evolution using the number keys on the keyboard while I'm developing and debugging. And also, for reasons that'll become clear in a couple of minutes, I've just put a cube of size 2 located at the origin. So in many cases when we create systems that are gravitationally bound, we have one very heavy central object, a star, a planet, and then satellites, spaceships, maybe some small moons. But really you can effectively treat it as, the one central body influencing the objects in immediate orbit around it. When you get to two objects of more equal mass, the way in which they interact means that the sort of standard orbit calculations are a little bit different, and we have to do things in a slightly different way. But to demonstrate why that is, let's first just go ahead and create a couple of planets here of equal mass and just show what happens if we don't do that. So we'll start with something we'll call planet 1. That's an n-body that's at the origin and has a mass of, say, 1,000. And then we'll duplicate that, call it planet 2. It also has a mass of 1,000. We will give each of these a graphical object. We'll use a sphere. Let's make that, say, 5 units big in each case. And add a little bit of texture. So we'll just go down to some of the prefab images, or sorry, some of the resource images, and we'll grab a Neptune texture and we'll grab a Mars texture so that we can see they're different. Right now they're both on top of each other at the origin. So let's go ahead and place the planet in orbit using an orbit universal around planet 1. And say that it has a semi-parameter of 10. And if we look at it in the scene here and zoom out a bit, actually let's maybe make that a semi-parameter of 40. So we can see we're just using the standard orbit universal component where we would typically have a less massive object around a much more massive object. In this case, we don't. They're both of equal masses, and we're interested in seeing what happens. And in order to make that a little bit clearer, let's create an empty object here on planet 2 and add an orbit predictor so we can see the path. And this orbit predictor is going to say, what's my orbit around the center, planet 2, for this body? Pardon me, planet 1 for this body, which is planet 2. So we'll go to game mode. We've got maximize on play, and let's just have a look and see what happens in our scene here. So we do have a circular orbit, but you can see we're now drifting away from the center of mass, and if we speed things up, then the whole system goes off the top of the screen. Not really what we were looking for with regards to a binary planet. The reason the whole system goes off the top of the screen is the way orbit universal works is it gives planet 2 an initial velocity to establish a circular orbit. So that's an initial circular velocity that goes up. And so that means because there's not a corresponding circular velocity on planet 1 going down here, it means the net center of mass velocity is upwards. And so therefore, as a pair, the whole system drifts away from the origin. If we want to change that, there is an option in Gravity Engine for center of mass where we can say set center of mass to 0, 0. And that will ensure that as objects are added, we maintain a center of mass, in this case, at a position of 0 with this velocity specified, which is also 0. So with that checked, if we check the scene, we now do have our objects in a binary orbit around each other. They don't drift off the screen. But the orbit predictor here is showing the orbit around this body, and what it really should be doing is showing the orbit around the center of mass. Likewise, the orbit of planet 1 is about the center of mass. So in order to make this more controllable and the way we want it to behave, there's a new component in Gravity Engine called BinaryOrbit. And this BinaryOrbit replaces the old binary pair object because it does a few more things. So first we'll get rid of this set center of mass. We'll go to planet 2. We're going to remove this orbit universal script. So remove component. And we're now going to create a new game object, which we will call BinaryOrbit. And we're going to make the 2 planets children of this binary orbit component. And then we're going to go to the binary orbit here and add the binary orbit element. And now if we go to the scene view for this, it shows us that they're both in orbit around the center of mass, so it's offset both of their positions appropriately. And in this case, let's make the orbit a little bigger so we can make it size 40. That is not updating. Why are you not updating? Let's go back to our 2 planets and put them in as a binary system without making use of any Gravity Engine lockdown center of mass stuff. We may in fact want more than one binary in the system. Zeroing out the center of mass might become a bit annoying. Let's create a new empty game object, which we'll call binary, and place that at the origin. And what we'll do is we'll make the 2 planets children of this binary, and then on the binary itself we'll add the BinaryOrbit script. Implicitly, this creates an n-body of mass 0, which will track the center of mass of the binary system. And as we go into our normal XY view, we can see in the scene view that it's placed the positions in a binary orbit around the center. They have slightly different orbits because we have one with mass 1000, one with mass 800. The attributes of the orbit are controlled at the binary level, so the size of the orbit we can change here, and we can also change all of the orientation parameters in the usual way. And now if we go ahead and press play, we have a whole bunch of errors because we did not set up the center of masses for our orbit predictors. So in both cases, these want to be the binary system. And now when we go ahead and press play, things look better. And we have our 2 systems, and the advantage now is we have orbit prediction around the center of mass for the binary system, and that will also work just fine if we add some eccentricity, and you'll see the same thing happen. And so that's a very convenient way to add a pair of binary objects into a scene. There's additional stuff we can do if we wanted this, for example, to be a binary planet system that is itself in orbit around something else. We can do that in much the usual way. So if we want to add another object in the scene that we call, say, star, we'll place that at the origin. And we'll give it a mass that's, say, 100 times as big as the binary, so it's fairly heavy. And then we'll, on this binary object, we'll just go ahead and, as we would normally if we wanted to put this in orbit around something, add an orbit universal around the star. Now this binary has an orbit of about 20, so let's put this at say 150 around the star. So now if we go into our scene and come way out, you can see that we have out here our binary system and we have the star here. We did get a few errors here as we added the orbit before we filled in the center end body. That's the kind of thing you might see as you dynamically create systems in the editor. We'll just close those down. So now we have a star that's fairly heavy, a binary, so we should have these guys in binary orbits, and we can go ahead and press play. And we see that our binary system is moving around the star. We didn't actually put a sphere on the star, but we can see that the orbits are changing, and that's because we have three-body interactions, and in fact, as is commonly the case, somebody gets ejected because the dynamics of three-body systems are quite complicated. Let's first create a sphere here on the star, say of size 10. And we can go ahead and give it a material. Let's say solar. Doesn't look very solar. Oh, sorry, that's a solar cell. I want a different material. Let's just use Jupiter. So if we don't want this tidal disruption, well, not tidal disruption, but gravitational disruption of the binary planet system here, this binary will be better coupled if the objects are close together, but perhaps we don't want that. So we can, if we wish to, go ahead and turn the binary into a Kepler evolution system and make that move in a Kepler evolution around the star, and now we'll get more of a clockwork binary system. It's not the actual n-body dynamics, but if in your game you wanted to have a binary planet system close to a central star and have it operate in that way, then you could go ahead and do that. So you can see we have this binary system. It's no longer distorting because it's in Kepler mode, so it's just drawing the binary orbits around the center of mass, and the center of mass is moving in Kepler mode around the central star, so everything is on rails and we don't get the tidal disruption that would actually happen if you used n-body physics with these mass values. That finishes our discussion of the binary orbit, which is a pretty handy component if you want to work with masses of equal mass.